My name is Raul Cano. I work in Aqualia at the Innovation and Technology Department, and I would like to explain to you a series of projects we have put in place here at the El Toyo purification plant, wastewater treatment plant. So we're not going too far away. And we have implemented a series of projects, microalgae based and biofertilizers, starting with wastewater. We're very much centered in the issue of improving water purification systems in a sustainable fashion and generate added value products, using it or dealing with it as an opportunity more than as a residue, as a waste. But I'm going to start talking about general problems as a form of an introduction, the challenges of the current century, such as hydrological stress, water stress, the pollution of water sources and aquifers. They are right now a problem to deal with. On the other hand, the scarcity of resources, especially minerals for the production of phosphorus, and as a source of biofertilizers for agricultural resources, and then the energy crisis, all the expansion of alternative renewable energies and that energy dependency we have in our country, having to depend on external energy sources. And this can be dealt with by the search for new innovative techniques in water treatment that allow us to improve water management in a sustainable fashion. If we speak about water treatment, Aqualia is a nationwide company. We deal some 500,000 million cubic meters a year. It's a considerable volume. And the energy use linked to these treatment can be estimated as equivalent to some 25 million euros a year. So it's quite a costly process. And then that use of energy, that wastewater, is got energy in the form of nutrients, DQO, equivalent to some 2 kilowatts hour per cubic meter. The use of this energy in Spain for purification plant, with treatment plant, amounts to about 1% of nationwide consumption. And the management of slurry also meant about 8 to 20 euros per ton, which has an influence in the energy bill of municipalities. Also, there are difficulties in terms of reaching the limits, the discharge limits in terms of nutrients, nitrogen and phosphorus. And then there's the issue of reusable waters and the importance in arid areas such as Almería. So, we now see opportunities in terms of the use of wastewater, for example, reusable water, water as a source of nutrients, or the production of bioenergy through fermentation, methane production, which can be transformed into biofuels, or the introduction of biomethane into fuel systems. I'm going to focus on two technologies, especially the first one, the microalgae. which lets us produce power products, for example biofertilizers and irrigation water. This is a sampling plant, a showcase plant which is already working since June. At the El Toyo purification plant. And then the memory project, which means the use of an aerobic membrane process which allow for a recovery of energy and water for reuse. The microalgae technology allows us to reduce the cost, the operational costs of our waste treatment project, because residual water is rich in nutrients and CO2 is oxidized by bacteria thanks to the oxygen generated by microalgae, and because of feeding them with nitrogen and phosphorus. So there's a kind of synthesis which let us produce quality water and also produce biofuel or biofertilizers, other added value products through the reuse of microalgae. While Almeria, as I was saying, it's an area subject to great hydrological stress and microalgae needs solar radiation, so Almeria is a wonderful location because of the solar radiation profiles and temperature. So we need such conditions not just in summer but also all throughout the year, so that waste treatment plant works steadily. And also the large production needs a lot of water, currently coming from desalination processes or from aquifers, and you know the problems they have. At the El Toyo treatment plant, for those of you who do not know it, is a small treatment plant dealing with wastewater produced in the eastern side of the city. The city is over here, and the area between the airport and Retamar and El Toyo district is the plant to be located. It covers the needs for some 30,000 people. And the showcase project involves a full comprehensive treatment process. There's an initial sieve or filtering, and it is fed as raw into the microalgae reactor. The microalgae grow there, purify the water, and at a posterior process, flotation process, we divide this biomass through centrifugation for the production of biofertilizer, and the clarified water is regenerated tertiary through wetlands and smart irrigation system we are testing in real conditions. This would be a layout of the treatment plant. This is a conventional active sludge process, and the process is made up of the microalgae growing area and the separation or harvest inside, and tertiary and reuse treatment. And this is framed into two projects: the InCover project, the H2020. Aqualia cooperates with some other 20 companies from 7 countries, and the BioSol project, a live European project, which is shared with French companies and aimed at the production of small communities involved in water treatment. There you may see the raceway. We've been working for some 3 months in a stable fashion and producing the microalgae and purifying the water. And we are comparing 2 steering systems, the traditional paddle wheel and a LEAR or submerged agitator, which is a corporate patent. It reduces about threefold the energy demand the production has, and then the harvesting, and with the salt water we separate clarified water, and we abide by the discharge regulation. And on the other hand, we take thickened biomass out, about 4% solids, and after centrifugation it is dehydrated. It's got this appearance, so in the end it reaches about 13-15%, and with this concentration we have biofertilizer which can be used through the adequate hydrolysis and disinfection in the field. You may see the harvesting slab, the centrifuge, the storage tank. We are entering into the describing of this algae, and the protein content amounts to about 40%. So it's got optimal conditions for it to be used as a farming biostimulating factor because of the elevated content in amino acids. So we could produce some 120 tons every year of dry matter, and all the reusable water after harvesting, it is processed through these tertiary treatments, through planted filters or wetlands and solar disinfection, so water can be used in a smart irrigation testing field. This would be the wetlands. Different plants have been tested there, and the effluent is fed into the solar disinfection plant, which uses a series of solar panels which generate the electricity need to create chlorine and count on an disinfected pathogen-free effluent. There are some results here. From these pathogen analysis, and with wastewater with 5 to 10% of E. coli content, after the disinfection process we reach down to 0. And there are some pictures from the smart irrigation plant there with a pumping system. Here you may see the building process, and this is the lawn we are watering with the wastewater coming from the plant. We have done a cost analysis testing, and the difference between a conventional purifying plant in terms of initial investment, it involves about 20% of cost increase, and in terms of OPEX it is reduced to a third part of the initial cost. So we are very active in slurry management. There you may see a series of scenarios. I'm not going to delve much into that. And some 800,000 euros a year could be saved in a wastewater plant of this kind. Last, I wanted to introduce the Savannah project in terms of widening, enlarging the microalgae based processes, apart from half to large added value processes such as biostimulants, starting from wastewater. I don't know how I'm doing in terms of time. I just wanted to speak to you a little bit about the memory project, which is another kind of technology we have developed. We generate low-cost reusable water, but mainly small community focus. It's a modular plant which can be placed anywhere. It is based on anaerobic processes of membrane processes. It's also a live project, and raw urban wastewater is treated in an anaerobic reactor. We generate biomethane, and there's an ultrafiltering membranes which separates the anaerobic bacteria are kept into the reactor, and the final result is a nutrient-rich percolated water which can be used for irrigation. And the slurry produced by the system, which are produced in a small amount, could also be used in farming. This is a 40 cubic meter reactor at the showcase plant. This plant is in Ciudad Real, in Alcázar de San Juan.
Membranas de ultrafiltración.
And the ultrafiltration systems. And then we have the location. Alcázar de San Juan is in Ciudad Real in Spain. This is the purifying plant. And these are the pictures of the pilot plant. These would treat the flow for some 500 people in one single stage. And as the main result, it gets rid of the DQO in water, carbon about 50%. We are producing quality methane, methane-rich methane, so it is very easy to valorize it as a biomethane, so it can have a big added value, and the production of biosolids is very low as it is an anaerobic process, and the treated water is high quality water. Our results are being very good. And that's all on my side. Thank you.